Students, in this video I will be going through a couple exercises with you guys where I will be simplifying the product of rational expressions. So let's take a look. Now the instruction here says to simplify each expression and state the excluded values. Okay, so I noticed that in this question that's being displayed right now, I have two fractions being multiplied by one another. What you need to understand is these fractions, even though it looks very abstract, it is no different from multiplying fractions that you are familiar with. Okay, so take for instance, if I give you an example, let's say if I have 6 over 5 times 25 over 12, let's say something like this. Okay, so when you're asked to multiply these two fractions together, and by the way, these fractions are considered rational expressions. Remember, think back to the earlier lessons in this course when we talk about what rational numbers are. Well, these are rational numbers, and these expressions are rational expressions. So when we multiply these fractions together, okay, you always multiply across. Now, I don't know about you, but multiplying 6 and 25 together can be rather labor intensive, right? Especially, let's say if this wasn't 6, let's say, here, let me change the problem just slightly. Let's make this not 6, but 36. There you go. Ooh, okay. 36 fifths times 25 over 12. So, yes, we do multiply them together, okay? 36 times 25 over 5 times 12. We certainly do this. However, being that you guys are in this high school course called Algebra 2, we should be a little more flexible in our ability to multiply these fractions together. So what I need you to consider is, okay, perhaps we can break up these numbers into its factored form. And then after we break things up into its factored form, then we can consider how we can multiply these rational expressions together. So take for instance right now, okay, instead of multiplying 36 and 25 and dividing it by 5 and 12 times 12, I can actually rewrite this as 6 times 6 over 5 times 5 times 5 over 6 times 2. Now, why is it important for us to consider this? Well, that's because if you look at this, I have a 6 here and a 6 there. They cancel. The 5 and the 5 cancel, right? Anytime you have the same number in the numerator and denominator and they're dividing by one another, okay, we can certainly reduce them. And look how simple this process, this product now becomes. And look, and the 6 and the 2 also cancels. The 6 becomes a 3. My final answer here is 15. Look how much less work needed to be done to multiply these two fractions together. I mean, you could have, yes, certainly entered 36 times 25 in your calculator and divided that by 60 and be done with it. However, you know, we have to build our number sense here, which is one of the motivations for going through these exercises. Now let's try to make that connection with this example that I have here, okay? This is an algebraic expression, and let me tell you, it's no different from the example that I just went through with you. So let's take a look at this, right? I have 6x minus 10 over 3x minus 5. Are there any common factors that you can see? Perhaps maybe we can factor out in the first fraction there. I noticed that I can factor out a 2, right? So if I do that, I end up with 3x minus 5 over 3x minus 5, right? And then times, can I factor x squared plus 4x minus 60 somehow? Are there two numbers that multiply to negative 60 while at the same time add to 4? I believe that would be 5 and 12. No, 5 and 12 does make 60, but doesn't add to 4. What about 10 and 6? 10 and 6 would do it. So I have x plus 10 and x minus 6. And then the denominator, I have 2 times x minus 2. Okay? So if by looking at this right now, I notice that the 3x minus 5 cancels with the 3x minus 5. The 2 cancels out with the 2. And I am left with this expression over here. I'm left with x plus 10 times x minus 6 all over x minus 2. So that product ends up being this. Should you multiply the numerator out again? You really don't have to, but if you really want to, you can certainly. This is another way of expressing it. It's x squared plus 4x minus 60 all over x minus 2. This is an alternative, okay? Now, there's another thing that you have to do, okay, with these simplification or these products that you're finding, and that is finding the excluded values. Now, these are rational expressions. Though they are equivalent right now, okay, it is important for you to state certain values of x that that cannot be substituted into either one of these things that I've circled here. Again, x cannot, there are certain values of x that are restricted here, and there are certain values of x that are restricted here that we need to state. This is the domain, okay, that you're stating, right? So what are the values of x, okay, that we cannot substitute in here? Well, if you look at this, okay, x cannot be 2, right? Because if x was 2, then this would be undefined. Why? Because if x were to equal to 2, then the denominator will be 0, and we cannot divide by 0. What about the left-hand side of the equation? Well, the left-hand side of the equation, okay, we cannot have x be 5/3. If x were to equal to 5/3, then again, all of the left-hand side will go to 0. 2x minus 4, again, x cannot equal to 2. So these are our excluded values. You need to check for the excluded values, mainly on the left-hand side, because whatever exclusions, okay, that needs to take place on the right-hand side of the equation, it will mainly apply to the left-hand side. So when you're checking for the values that are excluded, all you got to do is just check to see the original expression that you're dealing with and state what the exclusions are. All right, let's take a look at the next one. Pause the video to see if you can find out, again, what this multiplies out to, okay, and state what the what values of v we have to exclude. Hopefully you guys had some time to think about this, so let's take a look. I have 30v plus 18, right? I immediately noticed that I can factor out a 6, so I can factor out 5v plus 6. And in the denominator, I can factor that to be, let's see, 5v, v. I need 30 there at the end there, so it has to be 6. And 6 and 10? No. 6 and 5? No. Let me see here. I need 30, but I need 47 to be in the middle. So that would be 10. And 3 then, because 5 times 10 is 50, 50 minus 3 is 47. But I need it to be negative, so this has to be subtraction, and then this has to be plus. And then times 9 minus 3v, I want to factor out a 3, and I'll end up with 3 minus v, divided by 3v squared minus 24v plus 45. I noticed that there's a common factor of 3, so that's v squared minus 8v plus 15. Can I further reduce this? Absolutely. So let's see here. What can I do? This whole thing, or the denominator, I get to factor this again, right? This factors into v and v. I need 15, so, and the middle to be 8, so it's got to be 5 and 3 then. And then this has to be minus, and this has to be minus. Okay, so something needs to be said about this situation here. Notice right now I have 3 minus v and v minus 3. They look really similar, don't they? Well, that's because they are the same, okay, with a factor of -1. So what do I mean by this? Well, 3 minus v is the same thing as, if I flip the order of subtraction, right? Are these two things the same? No. I have to place a negative sign out in front, okay? So in other words, okay, 3 minus v becomes v minus negative of v minus 3. So having this understanding, okay, this whole fraction one more time changes to this. And why am I writing it like this? That's because I noticed that there's a v minus 3 in the denominator. So if you look at this now, okay, I'm trying to multiply this across, but before I multiply across, I want to see if there are common factors between a numerator and denominator so I can eliminate. I see here that I have a v minus 3 with a v minus 3. And I have a, I made a mistake over here. This should not be 6, this should be 3, because 6 times 3 gets you 18. And then this guy here should be a 3, and this guy here should be a 3. That's what happens when you're talking to yourself, right? So here I notice that I have 5v plus 3, they will cancel. And is there anything else that I can cancel? It looks like I can cancel out a 3 and a 3. So the numerator, all I'm left with is just 6 and -1. So the numerator is -6. The denominator, I'm left with v minus 10 and v minus 5. And actually, you can leave your answer like this. So this is the same thing as, one more time, -6 over v minus 10 times v minus 5. You can leave your answer like this, or understand that this is also equivalent to -6 over v squared minus 15v plus 50. Okay? So depending on the situation, let's say if it's a multiple choice, you need to be comfortable in rewriting the final answer into different forms. Now finally, we have to state the values that of v that v cannot equal to. Okay? So looking at this, okay, again, whatever happens on the left-hand side of the equation, okay, would suffice. So looking at the factored form on the left-hand side of the equation here, so all of this, okay, I can see that v cannot equal to -3/5, right, because 5v plus 3 equal to 0. If I isolate v, I'll end up with -3v. -3/5 v. V cannot equal to 10 because v minus 10 is equal to 0, right? So it cannot equal to 10. V minus 5 equal to 0, so therefore v cannot equal to 5. And v minus 3 equal to 0, so therefore v cannot equal to 3. Okay? And these values of v that for numbers that v can equal to, okay, that also applies to my final answer on the right as well, okay, because you can see there v minus 10 and v minus 5, right? Okay, so these are the the answers, okay, for question 10. Let's take a look at the next one. All right, pause the video here, see if you can solve this on your own. So hopefully you guys had some time to think about this. Looking at the numerator, there's no immediate GCF. However, I can see that we can start factoring there. So this is 3x, and this is x. I want the last number to be 60, but the middle number to be 8. So what would that be? I can have 6 and 10. If I do that, then this would be 10 and this would be 6. 6 times 3 is 18. 18 minus 10 gives you 8. So that's the correct arrangement there. I want the last number to be negative and the middle number to be negative. So that means this has to be negative and this has to be positive, because I want the negative number to outpower the positive number. Looking at the denominator, 15x squared plus 41x minus 30. So this is going to be, let's see here, I want the middle number to be 41. Oh boy, this is getting a little tough. So let's see here. Let's say if this was 5x and this was 3x. And again, there are some guess and check involved, okay? I hate to say this, but you know that sometimes that is necessary. Two numbers that multiply to 30, so it's 6 and 5, or 3 and 10. 6 and 5, or 3 and 10. So if it's 6 and 5, I will not get 41. If it's 10 and 3, let's see here. If it's 6 and 5, I get 15 and 30. I won't get 41 there in the middle. If it's 6 and 5 like this, that's 18 and 25. I won't get 41 still. If it's 10 and 3, no, let's see here, 10 and 3, that's 30 and 15. That will get me 45. That will not get me 41. That's not good. Okay. Oh. So what is it? 5 and 12? 5 and 12. That's it. 5 and 12. No, not 5 and 12. 5 and 6. 6 and 5. No, I will not get 41 there. So I need to play around with this a little bit more. So let me see here. I want to get back to this. The numerator there, 10 and 27, right? So I have 10x, x, 9 and 3. So I have 9 and 3. That works. See, sometimes these things can just come to you, and then sometimes it takes a little longer. I want the middle number to be positive and the last number to be negative. That's not good. So it's 9 and 3 will not work. So I need 5 and 2, perhaps, and 9 and 3, 3 and 9, 3 and 9. Yes, that would work. 9 times 5 is 45. 45 minus 6 gets me 39. Okay, so then that means this will be plus and this will be minus. And then the denominator, 2x squared minus 7x minus 72. So this is easier because the leading coefficient there is prime. And I need 72. So 12 and 6. 12 and 6. Would 12 and 6 work? No. I need 72. 9 and 8. 9 and 8. So that will not work. It will be 9 and 8 like this. Because 2 times 8 is 16. 16 minus 9 gets you... 16 minus 9 gets you 7. Okay, and this needs to be negative and this needs to be plus. Okay? Okay, getting back to this over here, I need 41 in the middle. Jeez. Oh, that's right. It's 3 and 10. Because 5 times 10 is 50. 50 minus 9 gets me 41. You see, sometimes when you walk away and come back to it, you can see it better, okay? All right, so that means this is going to be minus. No, this is going to be plus, and this is going to be minus. All right. So now that we have this, okay, we're going to try and multiply this out. Okay, and before we do, let's see if there are any things that we can cancel out. So 5x minus 3, 5x minus 3, 2x plus 9 and 2x plus 9. And is there anything else? 3x plus 10 and 3x plus 10. So all of this just reduced down to x minus 6 over x minus 8. So the final answer here is x minus 6 over x minus 8. Now what are the values that v cannot equal to? Or I mean x cannot equal to. X cannot equal to 3/5, negative 10 thirds, negative 9 halves, and positive 8. So these are all the values of x that x cannot equal to. Okay?